Sure, I'll be the first one to say. If you live in Southern California, you probably don't use the term wind chill very often. But if you visit some other place, like you know that I lived in Chicago for 1 year of my life. In addition to that, I have family in Buffalo and I visit them sometimes. I go up to Yosemite and other places in the United States and in other places in the world for that matter. Wind chill is a common term. Here's what wind chill is about so that you can be cued in when you hear this term. As wind blows across your skin, what it's going to do is increase the evaporation rate of water from your skin. So in other words, the air is going to go across your skin and water is going to evaporate, go from the liquid state into the gaseous state, into the air from your skin. Increasing evaporation rates results in cooler skin because what happens is evaporation is a cooling process. It cools whatever the water is being evaporated from, in this case, your skin. When wind is blowing across your skin, it's going to increase the rate at which water is going to be evaporated into the air because new air passes over your skin, thus absorbing moisture, and the air itself never has a chance to become saturated from your body. Wind chill tells you how cold you actually feel based on air temperature, so the actual temperature of the air combined with the velocity of the wind. The higher the velocity, the more water that's going to be evaporated off of your skin, and as a result of that, the colder your skin is going to feel. This graph is in the lab. If you take a look at it, here's what's going on. Along the top, we have actual air temperature in degrees Fahrenheit. And notice you kind of read this from left to right. So as you're going from left to right, the temperatures are getting colder. 50, 40, 30, 20, 10, 0, -10, and so on. Then notice on the left-hand side, we have wind speed in miles per hour going from top to bottom. Calm, 5 miles an hour, 10 miles an hour, 15 miles an hour, and so on. What we're going to do is combine a number from the top with a number from the left-hand side, and we're going to get what you actually feel like as a result of the temperature being a certain thing and the wind being a certain other thing. So here's what I've circled. The air temperature is 40 degrees. Again, this is probably why in Southern California you don't speak about wind chill very often because we don't have 40-degree air very frequently in Southern California. And the wind speed is 20 miles an hour. What are you going to do? This. You drag down away from the 40 and off to the right away from the 20, and where they come together, you reach 18 degrees, which means if the air temperature is 40 degrees and there's a 20-mile-an-hour wind and you're out in that air, you're going to feel like it's 18 degrees. I can assure you of something. 18 degrees feels a lot different than 40. Let's try another one. Let's say that the air temperature is 20 degrees and there's a 35-mile-an-hour wind blowing. I've been in this many times back east. Watch what it is. -20. Okay, that's getting cold. You are going to feel cold in that kind of air. 20-degree air, you're going to feel chilly in. -20, everyone feels cold in that. Want to try one more? Take a look. Let's say that it's 30 degrees with a 25-mile-an-hour wind. Okay, I'm not going to show you. You take a look at it. 30 degrees with a 25-mile-an-hour wind. Answer would be 0 degrees. Excellent.